Alright, here are the answers for the 17.1 homework for the liquid vapor equilibrium. Number 19 says, use the ideas developed in this section to explain the following. A. Perfume feels colder than water when both are sprayed onto the skin at the same temperature. Why? Well, since you can smell perfume, that means it is volatile, which, remember, is the ability to evaporate at room temperature. And because it has a smell, it evaporates sooner than water. Therefore, the hottest particles leave first, leaving cooler particles behind. B asks, meat that is cooking has a much stronger smell, than cold meat, for that typo. So as you're cooking, you are increasing the kinetic energy in the particles. When you're increasing kinetic energy, you are going to cause some particles to evaporate, which is what we smell. Therefore, some of these meat particles evaporate. That means they're turning into a vapor, and we can smell that vapor due to the increasing kinetic energy of cooking. If equal volumes of alcohol and water are spilled, the alcohol will dry up more quickly than water. Well, the alcohol has lower or weaker IMFs. Remember, water has extensive IMFs. Therefore, the alcohol evaporates easier. And in an open system, the alcohol disperses when it becomes a gas. Question number 20. Which of the following would you expect to have a higher molar enthalpy of vaporization? So that means our delta H of vaporization. And why? We would expect between ammonia and phosphine, ammonia to have the higher delta H vaporization because it has hydrogen bonds versus dipole-dipole, which is what these guys have. Hydrogen bonds are stronger intermolecular forces, so they're less likely to evaporate at room temperature. Therefore, they need more energy to separate. Between methane and methanol, methanol has hydrogen bonds versus van der Waals. Same explanation as above, hydrogen bonds are stronger than van der Waals, thus keeping the molecules tighter together, requiring more energy to separate those forces. H2O and H2S, same situation. H2O has extensive hydrogen bonds, and H2S is just a dipole-dipole. Therefore, it has a weaker attraction of intermolecular forces. Question 21. A sealed container at room temperature is half full of water, so it's a closed system. The temperature of the container is increased and is left for equilibrium to reestablish, so we are increasing temperature. Which statement is correct when the equilibrium is reestablished at a higher temperature? Going through each of these. A. The rate of vaporization is greater than the rate of condensation. That means you are not at equilibrium. The amount of water vapor is greater than the amount of liquid water. We cannot determine that unless we know the situation in which we are in. The amount of water vapor is greater than it is at a lower temperature. That is true. Because we're increasing temperature, you favor the increase of gas. Therefore, you are going to increase vapor pressure, and there's just going to be more vapor present. The rate of condensation is greater than the rate of evaporation or vaporization. Again, that means we're not at equilibrium. So the answer to this question is C. 22. A liquid and its vapor are at equilibrium inside a sealed container. What change would alter the equilibrium vapor pressure of the liquid in the container? Adding more liquid. This is only increasing the volume. That has no effect on the vapor pressure, only on equilibrium, the position of equilibrium. Adding more vapor. Again, this is just increasing volume. You're not changing the vapor pressure on the liquid. Decreasing the volume of the container. Again, adding volume, having no effect. And this is also surface area. Decreasing temperature. Temperature and the nature of the substance, so your IMFs, are the only two things that can affect vapor pressure. Therefore, your answer is D.